Hi guys, welcome to In 5 Minutes. We are handling memory management right now. The next topic in this is segmentation. What exactly segmentation? Well, it can be compared greatly with paging. In paging, the concept was fairly simple. We used to take a physical memory, or rather a file, break it down into several pages. These pages would store, or rather would give a logical references which were stored in a memory. So data was divided in pages and memory was divided in frames. A page which we used to take would be stored in a particular frame. That was a concept called paging. Even in segmentation, we have near about the same concept, but the difference is where each page was of equal size. Each page was of equal size compared to each other. Now we are not dividing it in pages, we will be dividing it in segments. What is a segment? How would you define a segment? Well, segment technically can be understood as logical related data, or few books also says logically related data is a segment. What are the different segments we have? Well, in a given program we would have stack segment, we would have symbol table that includes variables, identifiers, references, the main code which runs, the subroutines which we will be using, and some special functions which we have. We have all these things sorted down in a different logical addresses called segment. So when it comes to segment, how would you address it? When it comes to the segment, the concept of segment would be fairly simple. Depending on whether it is a data segment, code segment, stack segment, or extra segment, each segment will have a base, which means from where it is starting, and it is combined with a limit. Each segment can be stored in a continuous memory but at some different location. So when given a particular code or a line of instruction, we first would require a segment ID denoted by S. This would decide which segment we are trying to access. Once the segment is clear, we will be targeting the limit and the base register for it. And then using that limit and base register, we would understand which segments and access should be given. So here we'll be having a segment that would decide which entry we want to talk about. That segment entry would have limit and base register that will give us the information and will provide us the access to needed part of the data. Okay. Now, let's also try to understand how this diagram is doing at bottom. Given a particular segment, given a limit and base, we need to check that the offset, that is D, let's put it that way, offset D is within the range or not. If it is not within the range, then there is some error and hence no addressing would be performed. Otherwise, we would add limit and base register with the offset and get the access. Consider one example with values. Some X segment is located at 1000 and the limit is 500. So together it would become 1000 to 1500 as the address. Now, maybe we are talking about, let's say, segment X. That would be accessed as the Xth segment. It would get details as 1000 and 500. The offset which we are trying to access, consider that can be 100. Now what would happen? First of all, we will check whether this segment holds it. Let's say it is 1200 as the offset which we are saying. So we will go with the base and limit register. We will check whether it is falling within the limit. Then we'll go to the next one, and then we will simply add two values and come out with 1200th location. That 1200th location is where we are trying to achieve.